provide a safe and National Electrical Code compliant installation for test stands with electro-pneumatic actuators, several measures should be implemented. These measures encompass physical barriers, electrical disconnects, cord management, grounding and bonding, water protection, and employee training. Firstly, consider installing physical barriers such as a splash guard around the test stands to prevent water from splattering onto the cords or electrical component. Secondly, placing the test stands on a raised platform can create a separation between the water flow and the cords. Thirdly, electrical disconnects are essential. Install separate disconnect switches for each 90 to 100 volts direct current cord. Ensure the disconnects are accessible and clearly labeled for easy operation. Consider installing a master disconnect switch to cut power to all units simultaneously for maintenance or emergencies. Fourthly, implement effective cord management practices. Secure the 90 to 100 volts direct current cords with cord clips or wraps to prevent them from falling into the sink. Provide cord hooks or loops in the test stands to keep cords organized and prevent them from becoming entangled. Fifthly, focus on grounding and bonding. Verify that the test stands and all electrical components are properly grounded and bonded according to National Electrical Code requirements. Ensure that the disconnects and cord caps are grounded. Sixthly, water protection is critical. Use waterproof enclosures for the disconnects and cord caps. Seal any openings where water could enter the electrical components. Seventhly, employee training and procedures are paramount. Provide employees with written instructions on how to safely work on the test stands. Train employees in the location and operation of the electrical disconnect. Establish a clear procedure for connecting and disconnecting the 90 to 100 volts direct current cords. In addition to these core measures, there are additional considerations. Use high voltage, specifically 100 volts direct current, rated cords and cord caps for the 90 to 100 volts direct current connections. Inspect the cords and cord caps regularly for damage or wear. Consider using a remote interlock system that automatically disconnects power to the test stand when the main disconnect is opened. Display warning signs in the area to alert personnel of the presence of high voltage circuits. When installing electrical components in wet locations, it is essential to adhere to National Electrical Code Article 430.11, which covers motors, motor circuits, and controllers. Article 430.11 states that electrical equipment must be suitable for the environment. This means selecting equipment that is designed to withstand exposure to water and other environmental factors present in the test stand area. Furthermore, to ensure grounding and bonding compliance with National Electrical Code requirements, refer to Article 250. This article provides detailed guidelines on grounding and bonding electrical systems to minimize electrical shock hazards. It is essential to follow these guidelines to ensure the safety of personnel working with the test stands. For selecting appropriate overcurrent protection devices such as fuses or circuit breakers, consult National Electrical Code Article 240. This article outlines the requirements for overcurrent protection to protect electrical circuits and equipment from overloads and short circuits. Selecting the correct size and type of overcurrent protection device is crucial for preventing electrical hazards. In addition to these National Electrical Code articles, it is essential to consult with local electrical codes and regulations to ensure compliance with all applicable requirements. Local codes may have additional requirements or restrictions that must be followed. The National Electrical Code provides guidelines for electrical installations, but it is not a substitute for proper training and knowledge. It is recommended that qualified electricians or electrical engineers be involved in the design and installation of the test stand electrical systems. This will help ensure that the installation meets all applicable codes and standards and is safe for operation. Consider the use of ground fault circuit interrupter protection for personnel. Ground fault circuit interrupters are designed to protect individuals from electrical shock by detecting ground faults and quickly interrupting the circuit. Installing ground fault circuit interrupters in the test stand area can provide an additional layer of protection for personnel working with electrical equipment. When selecting electrical enclosures for the disconnects and other components, choose enclosures that are specifically designed for wet locations. These enclosures are typically made of non-corrosive materials and have features to prevent water from entering and damaging the electrical components inside. Enclosures should be National Electrical Manufacturers Association 4X rated or higher for wet environments. Implement a lockout-tagout procedure for disconnecting power to the test stands for maintenance or repairs. This procedure involves isolating the electrical supply to the equipment and applying a lock and tag to prevent accidental re-energization while work is being performed. Lockout-tagout procedures are essential for ensuring the safety of personnel working on electrical equipment. Regularly inspect and test the electrical systems of the test stands to identify any potential hazards or problems. This includes checking for loose connections, damaged wiring, and proper grounding. Regular maintenance can help prevent electrical accidents and ensure the continued safe operation of the equipment. In addition to providing written instructions for employees, consider providing hands-on training on the safe operation of the test stands. This training should cover topics such as electrical safety, lockout-tagout procedures, and emergency procedures. Hands-on training can help employees develop the skills and knowledge necessary to work safely with electrical equipment. Consider the use of flexible cords and cables for connecting the electrical components of the test stands. Flexible cords and cables are designed to withstand repeated bending and flexing, which can help prevent damage and ensure reliable electrical connections. Choose cords and cables that are rated for the appropriate voltage and current requirements of the equipment. When routing electrical cords and cables, avoid running them across walkways or areas where they could be damaged or create a tripping hazard. Use cord protectors or cable trays to protect cords and cables from damage and to keep them out of the way of foot traffic. Ensure that all electrical equipment used in the test stand area is listed or labeled by a recognized testing laboratory. This indicates that the equipment has been tested and meets safety standards. Only use listed or labeled equipment to ensure the safety of personnel and prevent electrical hazards. Regularly review and update the safety procedures for the test stands to ensure that they remain effective and compliant with applicable codes and standards. Changes in equipment processes or regulations may require updates to the safety procedures. Keep the procedures up to date to ensure the safety of personnel. When working with electrical equipment, always use appropriate personal protective equipment such as insulated gloves, safety glasses, and footwear. Personal protective equipment can help protect personnel from electrical shock, burns, and other hazards. Ensure that employees are trained on the proper use of personal protective equipment. Implement a system for reporting and investigating electrical incidents or near misses in the test stand area. This can help identify potential hazards and prevent future incidents. Investigate all incidents thoroughly and take corrective actions to prevent recurrence. In addition to the specific measures outlined above, it is important to foster a culture of safety in the workplace. This includes promoting open communication, encouraging employees to report safety concerns, and recognizing employees for their commitment to safety. A strong safety culture can help prevent electrical accidents and create a safer work environment. When selecting electrical equipment for the test stands, consider the ambient temperature and humidity levels in the area. Choose equipment that is rated for the appropriate environmental conditions. High temperatures and humidity can affect the performance and lifespan of electrical equipment. Ensure that all electrical connections are properly tightened and secured to prevent loose connections, which can cause overheating and electrical hazards. Use appropriate tools and techniques for making electrical connections. Regularly inspect electrical connections for signs of corrosion or damage and replace them as needed. When working with electrical equipment, always energize the circuit before performing any maintenance or repairs. Use a voltage tester to verify that the circuit is de-energized before touching any electrical component. Follow lockout-tagout procedures to prevent accidental re-energization of the circuit. When installing electrical equipment in the test stand area, ensure that there is adequate ventilation to prevent overheating. Overheating can damage electrical equipment and create a fire hazard. Provide ventilation through natural means or through the use of fans or other mechanical ventilation systems. When selecting electrical wiring for the test stands, choose wiring that is rated for the appropriate voltage, current, and temperature requirements of the equipment. Use wiring that is suitable for the environment in which it will be installed. Follow National Electrical Code guidelines for wiring sizing and installation. When installing electrical conduits, use appropriate fittings and supports to ensure that the conduit is properly secured and protected from damage. Use conduit that is suitable for the environment in which it will be installed. Follow National Electrical Code guidelines for conduit installation. When working with electrical equipment, avoid wearing jewelry or other metal objects that could come into contact with energized circuits. Metal objects can conduct electricity and create a shock hazard. Remove jewelry and other metal objects before working with electrical equipment. When cleaning electrical equipment, use a non-conductive cleaning solution and avoid spraying water directly onto electrical components. Allow the equipment to dry thoroughly before re-energizing it. Follow the manufacturer's instructions for cleaning electrical equipment. When disposing of electrical equipment, follow proper disposal procedures to prevent environmental contamination. Dispose of electrical equipment at a designated recycling facility or through a qualified waste disposal company. Avoid disposing of electrical equipment in landfills or other unauthorized locations. When working with electrical equipment, be aware of the potential for arc flash hazards. Arc flash is a dangerous electrical explosion that can cause severe burns and other injuries. Wear appropriate arc flash personal protective equipment when working with energized electrical equipment. Follow safe work practices to minimize the risk of arc flash. Implement a system for tracking and managing electrical equipment in the test stand area. This can help ensure that all equipment is properly maintained, inspected, and tested. Keep records of all electrical equipment, including its location, installation date, maintenance history, and testing results. When selecting electrical equipment, consider the energy efficiency of the equipment. Choose energy-efficient equipment to reduce energy consumption and lower operating costs. Look for equipment that is labeled with the Energy Star logo or other energy efficiency certifications. When installing electrical equipment, consider the accessibility of the equipment for maintenance and repairs. Ensure that the equipment is located in a place where it can be easily accessed for servicing. Provide adequate clearance around the equipment for maintenance personnel to work safely. When working with electrical equipment, be aware of the presence of underground utilities such as buried electrical cables or gas pipelines. Contact the local utility companies before digging or excavating in the area to avoid damaging underground utilities. Follow safe digging practices to protect underground utilities. When installing electrical equipment, consider the aesthetic appearance of the installation. Choose equipment that is aesthetically pleasing and blends in with the surrounding environment. Install the equipment in a neat and organized manner to create a professional-looking installation. When working with electrical equipment, be aware of the potential for electromagnetic interference. Electromagnetic interference can disrupt the operation of electronic devices and equipment. Shield electrical cables and equipment to minimize electromagnetic interference. When selecting electrical equipment, consider the reliability and durability of the equipment. Choose equipment that is built to last and is designed to withstand the rigors of the industrial environment. Look for equipment that is backed by a reputable manufacturer and has a proven track record of reliability. When installing electrical equipment, consider the ease of installation and maintenance. Choose equipment that is easy to install and maintain. This can save time and money in the long run. Look for equipment that has clear and concise installation instructions and is designed for easy access for maintenance. Ensure that all electrical boxes and enclosures are properly sealed to prevent the entry of dust, dirt, and moisture. Use appropriate sealing compounds and gaskets to seal electrical boxes and enclosures. Regularly inspect electrical boxes and enclosures for signs of damage or deterioration and replace them as needed. When working with electrical equipment, be aware of the potential for static electricity buildup. Static electricity can damage sensitive electronic components. Ground yourself before touching electronic components to discharge any static electricity buildup. Use anti-static mass and wrist straps to prevent static electricity buildup. When selecting electrical equipment, consider the availability of spare parts and service. Choose equipment that is supported by a readily available supply of spare parts and service. This can minimize downtime in the event of equipment failure. Look for equipment that is backed by a comprehensive warranty and a network of authorized service providers. When installing electrical equipment, consider the future needs of the facility. Choose equipment that is scalable and can be easily expanded or upgraded to meet future needs. Plan for future electrical loads and capacity when designing the electrical system. Regularly review and update the electrical safety program to ensure that it remains effective and relevant. Changes in technology, regulations, or work practices may require updates to the electrical safety program. Involve employees in the review and update process to ensure that their concerns and suggestions are addressed. Continuously improve the electrical safety program to create a safer and more productive work environment. Northern Illinois experiences a range of weather conditions throughout the year, including hot summers, cold winters, and frequent precipitation. These conditions can impact the electrical systems of the test stands. Extreme temperatures can affect the performance and lifespan of electrical components. High humidity can lead to corrosion and moisture damage. Snow and ice can accumulate on electrical equipment and cause damage or malfunctions. Therefore, it is essential to select electrical equipment that is rated for the specific environmental conditions in Northern Illinois. Choose equipment that is designed to withstand extreme temperatures, high humidity, and exposure to snow and ice. Use waterproof enclosures and sealing compounds to protect electrical components from moisture damage. Regularly inspect electrical equipment for signs of corrosion or damage and replace it as needed. In addition to the weather conditions, other environmental factors in Northern Illinois can also impact the electrical systems of the test stands. These factors include air pollution, dust, and vibration. Air pollution and dust can accumulate on electrical equipment and cause overheating or malfunctions. Vibration can loosen electrical connections and damage electrical components. Therefore, it is essential to select electrical equipment that is resistant to these environmental factors. Choose equipment that is designed to withstand air pollution, dust, and vibration. Regularly clean electrical equipment to remove dust and debris. Use vibration dampening mounts to minimize vibration. In addition to the specific environmental factors in Northern Illinois, it is also important to consider the general safety requirements for electrical installations. These requirements are outlined in the National Electrical Code and other applicable codes and standards. Follow all applicable codes and standards to ensure the safety of personnel and the protection of property. Obtain all necessary permits and inspections before installing or modifying electrical systems. Work with qualified electricians and electrical engineers to ensure that the electrical systems are properly designed, installed, and maintained. Regularly inspect and test electrical systems to identify and correct any potential hazards. Provide employees with ongoing training on electrical safety procedures. By taking these precautions, it is possible to create a safe and reliable electrical system for the test stands in Northern Illinois. Remember that electrical safety is an ongoing process. It requires constant vigilance and attention to detail. By following the recommendations in this guide, it is possible to minimize the risk of electrical accidents and ensure the safety of personnel.